Okay, I guess I'm a bit of the black sheep here. I'm not affiliated with academia anymore. Been moved on to the kind of industrial side, so I thought I'd just basically take some examples of what we've been doing over there and try to reflect a little bit on kind of how actually very relevant it is what is being done here in the, well, in Erkki's group. Well, that I know best for myself, but still. So first, last night I took a look at my old my thesis paper and just noticed that, okay, I've been drawing a lot of boxes, doing a lot of things, and there's actually that one thing that I still remember well, the kind of PDA recognition system. So technology indeed advances. Now you have your iPhone 5s, then you had something that was, well, not so much fun to program on, I'll tell you that. Right now we're doing more boxes, but they're more colorful at least, so if there's some difference there within these two pages. So what we're doing at CompTel is looking at, in a way, predictive analytics machine learning in a more practical industrial sense. Some of you might know about CompTel. It's a software vendor for mobile operators. Doesn't really sound like the first place you'd put predictive modeling and machine learning into. But there is a bit of a history, and I'll walk you guys through it in a few moments. But first I'd like to stop on one thing. So there's this term called data scientists nowadays. And I actually kind of renamed my team to data scientists as well. The term came up, I think I first heard it about 4 years ago maybe, in an event in Las Vegas actually. It was the first time I heard talk about this. So, but there's some fun things like people say, well, firstly, of course, if you look at it from the top, when data scientists believe that, are they going to be important? Well, yes, I think that's for given. You want to be important yourself. When you ask also others, talent in the workspace, so 2/3 think that this is something that's going to be a shortage of in the future. By 2015, the big data demand and big data and kind of data science, machine learning, it's all intertwined nowadays, to be honest. So 4.4 million jobs, but only one third of those will be filled. And it's the sexiest job of the 21st century, that's also a good point. But when you think about this, what does it really mean, what kind of data science? It's essentially what you do with machine learning, pattern recognition, clustering, all these kind of things that you've been studying here and keep on studying here, and put them into practical use. It's basically when you move out of the academia and move into the industry, you can be called a data scientist instead of a kind of real scientist. But that's still, it's still fun. So again, a bit about CompTel and what we do is process mobile operators' data. So one of them, actually, I was glad to notice on Erkki's slides also, there was this call detail records, in a way mentioned as one of the big data sources. So that's what we work with mostly. Traditionally, CompTel has been building software to mediate mobile phone calls for the last 26 years, and also kind of activate services on the network. But in about, well, it was February of last year, so there was but before that, CompTel, I'd say, adjusted their strategy a bit to become more competitive in the marketplace, and we wanted to build this kind of analytical capability on top of what they're doing. So I think that's also very good to note that in this case, when they started looking around, what should they do? They found a smaller Finnish company called Extract, which many of you might have heard about. So myself and quite a few of the people, actually we have Jaakko here in the room right now. We have had a lot of people who have come from the laboratory and from kind of, we have Janne Sinkkonen who's been there, Timo Similä is there with me now, Markus Ojala, a lot of people who have kind of come from this kind of institution and been a part of the Extract history over the years. So we were acquired by CompTel, and now we came into the kind of software company to fulfill the part of bringing intelligence into what they're doing. And I'll tell you, that's a bit of a mismatch in cultures in some ways. So most of the people having gotten their doctorates here and then going into a very software-oriented environment. But I think we're slowly starting to win it over, I'd say, when we're doing things that way. What we want to do is, in a way, provide additional value. So if you look at it from the perspective of what companies do, it's a public company, it's in the stock exchange, you can buy shares on the market, so it means that we need to generate value for our share owners. So essentially, we need to make money. So that's the kind of biggest difference, I guess. So but how do you make more money for your shareholders when you provide value to your customers within another kind of companies in CompTel's case? So just some examples. So what we're trying to focus on is combining these. CompTel has traditional capabilities on event processing. There's a lot of things in the medium platform. There's actions you can take, of course, because intelligent without any action, when you look at it in the practical sense of providing value, it's not really that important. So I can tell many stories on the kind of days, mainly at the extract also, but also recently, when we'll be doing very nice machine learning algorithms, churn prediction modeling, and then we hear from the customer that, okay, what did you do with these results? We store them into our database. What did you do then? Well, they're still there. So nothing happens. So that's kind of the thing that you start to see more when you're kind of feeling a bit of the pain that you actually want something to happen. So it's the action part that really counts in the end. How do you provide additional value? And we're kind of trying to, in a way, just a slide a bit illustrate. And I actually wanted to show a quick video here in between. I wonder if that my YouTube link works or not. But what we're looking to do is, in a way, combine the kind of real-time analytics. So there's a lot of complex event processing capabilities, fast data, in addition to just the kind of big amounts of data. Combine that with the big data, utilize machine learning, and essentially a lot of different algorithms in there, regression modeling, clustering algorithms, some dimensionality projections to make the data more feasible as you have these nasty variables. In the mobile operator space, also like phone models or things that you have just very categorical, how do you make those relevant for your modeling activities? Combine that, basically make the operational outcomes, decisions based on this. I'll just see it's There's actually audio on this one too.
Cocktail Social Links continuously analyzes staggering amounts of information. For example, CDRs, quality of service, and billing data. The mobile usage of every single one of the operator's customers is used to create a social network. The social network information, along with up to 1,000 other variables, is analyzed for each customer. Social Links uses this information to solve specific business problems by first identifying sample customers based on historical data. Based on the sample customers, advanced algorithms automatically define the similarity of each customer compared with the samples. Once all customers are scored, they are ranked in order to allow the marketer to choose the most suitable customers for the target group.
I think that's actually a bit of a funny video because you're talking about Comptel and making data beautiful. So actually, when I first came to Comptel from Extract, we had I don't know if anybody remember Comptel, but they had this very kind of boring blue font, like a TypeScript font. And Extract had these kind of green colors and everything. So a couple of months after, by coincidence, but still, also Comptel became much more greener and visible in their colors. But still. So what we're doing is we're trying to build a product, or we have built a product. We're trying to constantly improve a product. So actually taking a lot of different components in. One thing that I've noticed personally, that when I was working on my PhD work and all kind of experiments, you wind up hacking up tens of thousands of lines of code, and then writing code around that to make sure that when it fails, you would do it again. I know probably just me because I wanted to get the results as quickly as possible, but still, the one thing that's I think the biggest difference is that you need to be able to deploy the solution to a customer premises where it's guarded by VPNs that you can't access, and be able to trust that it's actually going to keep on doing what you wanted it to do in the first place. So we had some, again, practical examples of that. VPN connections to customers going down, not being able to access the system when we wanted to, and still making sure that everything is up and running. But really at the heart of this whole solution is kind of what's marked as the use cases, but they're something that's driven by generating more intelligence. And again, we're going back to a lot of those contain a lot of the traditional steps. Of course, there's data coming in. We need to be able to process that data, store that data in different kind of technical solutions. There's underlying massively parallel processing databases. There's Hadoop components in there. But these are basically tools where you store the data. When you really get into something interesting is where you can derive information out of the data. So you start talking about extracting features to be able to build them, kind of build that information, the valuable information out of the data, and then actually do something with it, feeding it into a predictive model and getting that information out. And then again, kind of being able to combine this whole into a loop where you're actually getting feedback from the environment and adjusting based on that, retraining your models, hopefully being able to automate that as well, not worry about things going, well, not so well, but have enough robustness in the systems. I think it's fun to do. Some of the things, and why are, for example, our customers, focally the mobile operators in the kind of global market, interested in this, is that of course there are things like, well, Finland is an exception, so we all, I think, have postpaid accounts, so we're paying our mobile phone bills after the fact, kind of we get a bill home. But if you look at globally, it's a minority, so there are a lot of countries where the prepaid is so dominant that actually mobile operators don't know much about the subscribers at all. So any kind of information that we can provide on the subscribers is perceived as being, well, extremely valuable. It's much easier to kind of understand your consumers or your subscribers or your kind of customers when you actually know something about them. So we've been doing things like trying to predict demographics, gender, age as well as possible, having different kind of multinomial models in there to find the best kind of subgroups inside this, and have applied this again to a real customer in production. Another example, a recent one, is that a different type of a problem is that the network elements for a mobile operator, well, they tend to fail. There are problems as well, all software is not bug-free, and even technical devices tend to fail over time. So again, a use case where there's great value to be found for the operator is that if they can predict these failures in advance, find those elements that will fail sooner. And again, kind of things that, if you look at this kind of pipeline of things to do, very similar to any kind of a pattern recognition or machine learning tasks. You get a lot of data in, you find the features to extract from them, you generate the predictive model, you apply that model, you estimate the probabilities of each device failing, then you rank them in order of that, and try to kind of find something interesting information out of that. Understand why this could have happened, at least something that could help those experts to understand it. That's another point that I personally really like, that when you're in a way kind of acting as the machine learning expert in the field, sometimes you get to go to these entirely new situations where there's a domain that you don't necessarily know as much, which was also mentioned here several times. So whether it be kind of pattern learning and something well, information about the human brain, for example, in the measurements Ricardo mentioned. Well, here it was basically a bit more boring in terms of network elements, but still we were able to kind of uncover information that these experts in that domain hadn't never even thought about. So we're helping them even do their jobs kind of better. Again, another topic which is kind of fun to do. And I just wanted to kind of, as the last thing, discuss one practical example. So there's this kind of a Robi Aksela case study. And it's, well, don't need to read all the studies. I'll try to go through the most critical parts. It's essentially a big operator in Bangladesh who decided, and well, why I'm talking about this, it's one of our public references that I can talk about right now. And that's another thing that you breach in these things. Can't publish much and can't even talk about all the details, but luckily there are some cases you can discuss in more detail. So basically, an ongoing customer of Comptel's, we delivered a solution which has gone live just a few months ago, and now they're really starting to see the benefits of that. What they wanted to accomplish is essentially solve a few of those kind of key problems, and we call them use cases. So when you look at these use cases, there are things like churn prediction, a bit of a boring problem nowadays when you've been in the mobile operator space for a few years, but it's still a big issue. So operators would not want their customers to leave. They want to give them better service, or at least make sure that they stay, so give them an offer they don't want to refuse. But there's also a lot of different kind of aspects to this issue. And this is one of the key things that this Robi as a customer they were interested in. We're looking at it from different perspectives. So we have something like what we call rotational churn. There's the different types of people coming in, then they would want to change to a new kind of, there's often an introductory offer in these kind of prepaid packages. So you get, well, also in Finland, you get a bit more credits if you buy a new SIM card than if you use your old one, which from the operator's perspective, of course, doesn't make sense. They would much rather have them recharge which is much more cost efficient. So how do you detect these kind of subscribers that are actually coming back into the network after they have already used up their credits? They most likely be talking with some of the same subscribers, but it turns out to be a kind of a graph matching problem, which can be somewhat harder to solve when the graphs get very big and they're very dynamic, and these kind of, a lot of these people tend to be switching their SIM cards at almost the same time, but of course only when their credits run out. Some things that people kind of that tend to wait for offers, they wait until they get a good offer, only then want to pick up the usage again. Some have many SIM cards, and some basically just leave the operator for different kind of customers. But so I guess I just put this slide up because there's a lot of kind of, in my field of business, most of the time people talk about churn, but it's actually not so simple. A lot of interesting sub-problems to solve if you look at it from many perspectives. And that's kind of what we're trying to do. We're trying to really be the best, and that means that we address all of these kind of different topics instead of just making one simple model based on some demographic variables, which basically anybody can do. It's not really hard to use a kind of nowadays you use SPSS or R or MATLAB, take a few variables, just plug them into some algorithm, you get it off the net. But how do you really make that into something that's kind of exceptional of quality? I think that's when you really start to need this understanding. And that understanding is what, to me, comes from studying with people like yourselves and having had this background on really kind of being able to determine which are the approaches to take. And it's sometimes, even if it's not so much fun, it's useful to know the assumptions that are underlying all of these methods, so you don't make wrong conclusions and overfit your models and the usual stuff. So what we do when we have this kind of a churn use case is essentially all that we do. If you look at it very simply, so why it's hard to see a value of a solution like this is we essentially all we do is calculate a few numbers. So for every subscriber, you get out one number. So, but then how do you actually go in the kind of commercial world to sell those numbers to these kind of customers of yours? How much would you pay for one nice number here, which is going to be something between 0 and 1? And well, of course, then you have to be able to also prove that it is of value in the end. So how well do these kind of prediction accuracies match? You're actually trying to beat the competition all the time. There might be a reference method that you are comparing against, and in this case, just kind of one of the examples. In terms of predicting churn in a live environment, this kind of results of having almost half of the churners actually in this top 5 in a very dynamic environment like they had in Bangladesh. It's actually pretty good results. So the customers were very happy to see these things happening. But yeah, so that's just one example of kind of what we've been doing here at Comptel, and well, essentially what I've been doing since I left the university here, doing our stint in Extract. And for those like Jaakko who are here who know Extract, I had to have a picture of some social network graphs, which are still the same ones we had in the Extract slides here. So I think the history of these couple of slides is a couple of images over here. They've been in so many slides so far, and well, yeah. Anyway, but it's kind of one approach of looking at data. You have a lot of different data sources. There are a lot of kind of industrial problems, and this is of course only one of them. I really see a lot of benefit from being able to understand that data and formulate the problem that the business has into something that can be solved as a mathematical equation. Well, if not equation, but at least kind of approximated well enough to find something that provides real value to the customers. And to me, I'm very grateful for Erkki and well, others also here, former colleagues who were kind of, well, taught me a lot of the things that I've been trying to put into practice and help others also do in the past. So thank you, Erkki, and congratulations.